Hey, this is Mr. Ayton. This is the 2024 AP Chemistry exam. We're starting with the short response, the 4-point problems, and this is free response question number 4, the solution guide of the 2024 AP Chem exam. You can see it's a calorimetry problem, and the first one is trying to figure out what should the student report as the highest temperature. And so you got to use significant digits. You got to get one estimated number. We know it's bigger than 38, but less than 39. So we're going to guesstimate 38.5 degrees Celsius. If you guesstimate 38.4, 38.6, 38.3, you are good to go. So we know the highest temperature there. You can see it also gave us the mass of the metal cube, the mass of the water, the initial temperature of the metal cube, and the initial temperature of the water. And you can see as a particle level representation of the water molecules in the calorimeter before and after. Well, take a look. The water is a temperature of 25 degrees Celsius. We put in a metal cube at 100 degrees Celsius, which means the metal is going to lose heat. The water is going to absorb heat, and they're going to exchange the same amount of heat, which means the water particles are going to be moving with greater kinetic energy, a higher temperature, and therefore your lines of indicating speed has to be longer. That's probably your second point. And on to C. C says, assuming the metal transfers 2940 joules of thermal energy to the water, calculate the specific heat of the metal. Well, if the metal transferred 2940 joules, we know that's the Q. We're going to use Q equals MC change in T. The mass of the metal is 98.1 grams. The specific heat of the metal we don't know. And the metal started at 100 degrees Celsius and it went down to 38.5 degrees Celsius because it was giving off energy or giving off heat, which gives us a specific heat of 0.487 joules per gram degree Celsius. That low specific heat for a metal seems like a really good number. You're going to get 1.4C. Then part D. Part D said in a second experiment, 2940 joules of thermal energy is transferred to a different metal, to aluminum, 98.1 grams, still the same mass. But aluminum has a different specific heat capacity. You can see that specific heat capacity is 0.897 joules per gram degree Celsius. That's larger than the specific heat that we got of our unknown metal. And so it says explain how the magnitude of the temperature change, delta T, compares with the magnitude of the temperature change of the metal in the original experiment. So I'm just going right back to Q equals MC change in T. You can see because there was the same Q and the same mass, if the specific heat is greater, the change in temperature is going to be less. And we calculate the change in temperature to be 33.4 degrees Celsius. You can see the other metal changed close to like 60 some odd degrees Celsius. And so the delta T for the aluminum is much less than that of the delta T of the metal, since the specific heat of aluminum is greater than that of the metal. And that's your fourth point. This is the 2024 AP Chemistry exam, free response, question number 4. Check out all my other videos and check out MrAyton.com. See you guys. Catch you on the flip side.